Hello, my dear friend, welcome back. I am David Cortese and this is my website www.david-cortese.com. In this video, I'm going to talk about an important algorithm that is the bubble sort algorithm. It's very important. The bubble sort is one of the simplest sorting algorithms primarily used for educational purposes to demonstrate basic sorting logic. It operates by repeatedly stepping through the list, comparing adjacent elements, and swapping them if they are in the wrong order. The process is repeated until no more swaps are needed, indicating that the list is sorted. Though bubble sort is not efficient for large datasets compared to other algorithms like quicksort or merge sort, its simplicity makes it a useful teaching tool for introducing the concept of sorting algorithms. What it is? Bubble sort is a comparison-based sorting algorithm. It repeatedly traverses through the list, compares adjacent elements, and swaps them if they are in the wrong order. This bubbling process continues until the entire list is sorted. The name bubble sort comes from the way smaller elements bubble to the top of the list, front of the array, while larger elements gradually sink to the bottom end of the array. Applications: small datasets. It performs reasonably well when sorting small datasets, where simplicity is more important than speed. Nearly sorted datasets. In cases where data is already partially sorted, bubble sort can finish sorting with minimal overhead. Educational purposes. Bubble sort is widely used in teaching because it is easy to understand and implement and helps beginners grasp basic sorting concepts. However, due to its inefficiency for large datasets, it is rarely used in practical applications outside of learning environments. How it works? The basic idea of bubble sort is to start at the beginning of the list. Compare the first two elements. If the first element is greater than the second, swap them. Move to the next pair of adjacent elements and repeat the process until the end of the list is reached. After each complete pass through the list, the largest unsorted element is placed in its correct position at the end of the list. The process repeats, excluding the sorted elements at the end until no swaps are necessary, indicating that the list is fully sorted. Example: consider the list 52915. First pass, compare 5 and 2, swap 25915. Compare 5 and 9, no swap 25915. Compare 9 and 1, swap 25195. Compare 9 and 5, swap 25159. At the end of the first pass, 9 is in its correct position. Repeat the process for the remaining unsorted part of the list. Second pass, compare 2 and 5, no swap 25159. Compare 5 and 1, swap 21559. Compare 5 and 5, no swap 21559. Third pass, compare 2 and 1, swap 12559. Compare 2 and 5, no swap 12559. So the list is now sorted 12559. Here you can read the code of the C program. You can copy paste it inside code blocks and you can try yourself. Here there is the function to implement the bubble sort. So as you can see, the last elements are already sorted. Swap if the current element is greater than the next element. Then there is the function to print the array. You can study by yourself. You can try. The best method for learning coding is to try yourself using a compiler. I suggest you code blocks. On my playlist you can find how to download, how to install the software from the official website. It is an open source cross-platform IDE. And I don't know if you ever watched the movie Karate Kid. It is like wax on, wax off. Because by doing this exercise day by day, you will learn this job that is coding. You will be a software engineer. Believe in yourself that the secret is practice. The more you practice, the better you will be. So this is the main function. As you can see, it is the function where you can put the data and where you can write what is asked by the program. So the time complexity is of the bubble sort depends on the number of comparisons and swaps made to sort the array. The best case time complexity is O(n). In the best case scenario, already sorted the list. The bubble sort only needs to make one path through the list with no swaps required. Worst case time complexity O of n squared. In the worst case scenario, reverse sort the list. Bubble sort needs to make n minus 1 passes and perform a large number of swaps. Average case time complexity O(n squared). In most cases, bubble sort performs n minus 1 passes and makes multiple swaps during each pass. Space complexity. Bubble sort has a space complexity of O(1), meaning it is an in-place sorting algorithm, as it requires only a constant amount of additional memory for variables like I, j, and temp. Conclusion: while bubble sort is easy to understand and implement, its inefficiency on large datasets makes it unsuitable for practical applications. Its time complexity of O(n squared) in the average and worst cases makes it slow compared to more advanced sorting algorithms. However, its simplicity and educational value make it a staple in introductory programming courses. So you can find this PDF on my website. You can download it, you can print, you can study, you can share, you can do what you want. On my website you can find a lot of information about software engineering, web development, mathematics, physics, chemistry. You can find also a lot of games, music, and other material. So as you can see, there are many chess games like these. You can play against the CPU. You can chat with me using your email. You can sign up. You must sign up using your email, and then you will be able to chat with me. And dear friend, your donation is important. Help me update this website and join this community. Thank you for watching. See you next time. Bye bye.